This is Linda, and she's about to retire. She's done a good job of saving, but she and her husband may face a problem that many retirees are completely unaware of. In the next few minutes, we'll explore the problem, then reveal a new approach to solving it. Linda and her husband have big retirement dreams, but they don't yet know what they can afford. They hope for winter getaways in the Caribbean, a big trip to Italy one day with the whole family, even the grandkids, and finishing their mountainside retirement home. And like all new retirees, they'll have to answer two simple questions with complex answers. The first is, how should Linda invest the money she saved? There are many good answers, but this is not an investment discussion. This is about a critical second question she also has to answer. How much can she live on without running out? This second question on its own can determine her financial success or failure in retirement. She has to set the size of her steady, lifetime retirement paycheck, which, along with any other income, will define the lifestyle they enjoy for the rest of their lives. Take too much and they face running out early. Too little and they give up the life they could have safely afforded. In simple terms, what she wants to know is, what is the most she can take safely? Many financial professionals call this the maximum safe withdrawal amount. And for the answer, Linda turns to Gary, her financial advisor, who tells her to multiply the amount she has saved on her first day of retirement by 4%. This approach is called the 4% rule. Will it work for Linda? Unfortunately, with real-world factors considered, Gary learns that in the past it usually hasn't, which becomes a problem because he truly cares about Linda's success. It also leaves Linda with a very big and very real problem she's completely unaware of. So while Linda thinks about flying the grandkids to Tuscany, let's see what would have happened if she retired in the past. We'll compare 3 different retirement start dates, all starting within a 2-year period in the mid-1970s. Using the 4% rule, assuming she's retired for 30 years and what's called a balanced investment portfolio. We see 3 wildly different outcomes, and this clearly illustrates the big problem. The question was, what's the most she can take safely? Scenario 1 is the only success because she both maximized her income and didn't run out of money. In the second scenario, she ran out almost 10 years early, even though she did nothing different. We call running out early a downside failure. And in the last scenario, she chose a paycheck that was far less than the most she could have taken safely and gave up the lifestyle she could have afforded. We call this an upside failure. And this is not unique. This problem has occurred over and over again in the past. So what's the problem? According to new research, the problem is an up-to-now unrealized investment pricing error that's almost always present on any given retirement start date. And it can only be seen if history is looked at in an unusual and very specific way. So while Linda now dreams about building that mountain cabin, let's see what went wrong. When U.S. stock market history is looked at in a way that economists call real total return, its performance has closely tracked an amazingly steady trend for over 2 centuries, shown here in green. Sometimes it tracked very closely, but at other times it deviated, but never by more than about twice or half of the value of that trend line. From this, we can start to see a breakthrough that might help Linda and millions of other retirees find a more accurate answer to that critical second question. This chart actually shows 2 different values. The normal value we're all familiar with is tracked by the blue line, basically what you could sell something for. But you're about to see that the value defined by that green line, which we call internal value, has far more accurately defined available retirement income than that erratic blue line. What we really need to know is the difference between these 2 values, which we call the value gap. And we think this pricing error is the primary cause of the big problem. So let's zoom in on the period from 1900 to 1984, like this. And if we then graph 30 years of portfolio balances for only retirement start dates that ran out early, and put them all on the same chart, it would look like this. But the truly amazing thing, shown on the top graph in red, is that these downside failures only ever happened when retirement started in greatly overpriced markets, while upside failures only ever happened when starting in underpriced markets. So, if the problem is the starting price error measured by this value gap, then to solve it, we have to mathematically pretend that the portfolio is worth what the green line says instead of what the blue line says. So to cancel this error, we need to add a correction factor that's equal but opposite. If we do this, and then retest all of the failed outcomes shown below, the results would change from this to this. Success. Downside failures were completely eliminated, and upside failures were either eliminated or greatly mitigated. So to help Linda, we need to add this value gap factor. But there's one more thing. 4% is not always the right number. We call this number the target withdrawal rate and have found it's defined by these 4 factors. So when we make these 2 changes, align the target withdrawal rate, then cancel the initial pricing error, we call this new approach the value gap method. And while it's only 2 simple changes, it does require a lot of complex math, so we built a special tool to do all the hard work. Using updated historical data for many different investments, it determines both target withdrawal rates and value gap factors for dates right up to the present day. And with 5 simple inputs, it calculates both starting withdrawal percentage and a historically sustainable maximum paycheck size for a specific retiree. So while Linda dreams of that blue Caribbean water, let's finish by testing this method on the worst time in history ever to invest in U.S. stocks. September of 1929, the start of the Great Depression itself. Assume Linda starts with $100,000 invested all in U.S. stocks, but then starts her retirement income on 3 different dates. The first is right away, in the most overpriced stock market in U.S. history. It ends in tragic downside failure during World War II, and after the money runs out, we then continue to track how far behind she gets. In the second scenario, she starts income in a fairly priced market with a successful outcome. And finally, she starts in history's most underpriced U.S. stock market ever, at the very bottom of the worst market drop ever seen, resulting in the most spectacular upside failure ever seen. If we then introduce the value gap method, using data only from the past, we get value gap corrected numbers. If we then rerun these same 3 starting dates with the corrected numbers, the results change from this to this. Total success. Each outcome ended with around half of what she started with. This method just took on the worst market volatility in U.S. history and pretty much crushed it. Amazing. The level of improvement may be game-changing, and it could be a sound basis for helping American retirees try for better answers to one of life's most important decisions. And hopefully, it will let Gary help Linda and his other clients land on a better answer to that critical second question.